I'm going to explain sets and disjoint sets. Here I'm going to explain in this video, especially I'm going to explain what is set and what are the set operations we can perform on sets, and what is disjoint set definition, and how we can represent disjoint sets using tree structure format. Okay. Now, so what do you mean by set? We know. So collection of elements. So those collection of elements should be related. So what do you mean by set? The collection of elements is called as set. So generally we represent that collection within open and close curly brace. Open brace, write the number of elements and close it. So those are related each other. Like suppose set of even numbers. So what do you mean by set of even numbers? So generally we write all even numbers within open and close curly brace. Or a set of boys or set of girls. Means we are saying that the whatever the elements that are represented within open and close curly brace, those are related each other. Okay, na? Then what do you mean by disjoint set now? What do you mean by disjoint set? So there is no connection among the sets. Means if you write set of, or if you take set or collection of sets, how can you say these sets are disjoint? Means if there is no common element among all these sets, then we generally treat them as disjoint sets now. So this is the definition of disjoint set, and set is the definition of that. Okay. Now I am going to explain the operations of sets. What are the general normal operations we are going to perform on sets? Suppose if you see the operations, generally we perform union between the sets, union, and we can calculate the intersection among the given sets, intersection. Third one is difference. We can calculate difference between two sets, and fourth one is complement. We can calculate complement. I will show you by taking examples. And next operation is Cartesian product. And third one is equality of n tuples. And the last one is find. Okay, na? So these are the general operations we can perform on the sets. Now I'm going to explain all these operations by taking examples. First operation, union. So what do you mean by union? Suppose if we take two sets A and B, okay na? Suppose set A containing some elements and set B is containing some elements, okay na? A union B means we need to combine two sets. So while combining two sets, suppose if elements are repeated, we must consider that particular repetition one time only, okay na? So first write all elements in A, and start writing elements from B. Suppose if that particular element is already copied into A and B, don't consider it. So like that, so whatever the elements that are copied already, we are not going to consider. If you experience new elements in B, then only we are copying new elements into the resultant set A. Union B. Okay now, suppose now the union of A and B can be represented as A union B like this. This is the symbol for representing union. Okay now, so in set format we can write for all elements. Here what I am writing is for all elements X. Okay now, if you consider A union B, you can select any element in A union B, just treat it as X. Okay na? Then that X should be belonging to either A or B or both. You can write. Even sometimes the element may be belonging to both. Just here I am talking about normal set. I am not talking about disjoint set. Later I will tell you what is disjoint set, and by taking one example I will explain. Okay na? So here I am simply taking sets. Sets means the elements may be repeated. Okay na? In that case, while copying the elements into A union B, just completely copy first set, and while copying the second set, they simply omit the repetition and write all the remaining elements. Okay, like that I am writing. Suppose you can consider any element X, or for all the elements you can say for all the elements X should be belonging to either A or B or both. That is the definition of A union B. Then for this particular case, first write A, 1, 2, 3. Okay na? So 1, 2, 3 are already copied. Means first set I have copied completely. Then from second set, 1 is already copied, 2 is already copied. Then we are not considering these two. Then new elements are 5 and 7. Then copy 5 and 7 into resultant set. Now this is the A union B of the previous two sets. A 1, 2, 3, B 1, 3, 5, 7. So after copying 1, 2, 3, 1 and 3 are already copied because no duplication is allowed in A union B. Then the remaining two elements are 5 and 6. Now this is the resultant set of the given two sets. Now this is set because the repetition elements are repeated. Then what about the disjoint sets? In disjoint set, suppose A equal to 1, 3, 5, B is 7, 9, 10, 11. Then these two are disjoint because there is no common element. Then blindly we can copy all elements from A and all elements from B into resultant set because there is no common element here, because that set is disjoint. both the sets are disjoint. I have already told the definition. What is the definition of disjoint sets? If there is no common element in both the sets, means there is no repetition. There is no repetition among the two sets. Then directly copy first set, and followed by second set. Need not worry about whether repetition is there or not, because these two are disjoint. Then the disjoint sets union is 1, 3, 5, 7, 9, 10, 11. 1, 3, 5, 7, 9, 10, 11. But normally, if you want to show the union using Venn diagram, this is Venn diagram. And we are showing the sets as circle, and within the box means the square. Within square, we are representing those two circles. Then what do you mean by A union B? We are combining all the elements of A and all the elements of B. Means this entire part is A union B. This entire part is A union B. Is it clear now? So if you want to show the Venn diagram for A union B, consider A and B completely. See here, we are considering intersection part one time only. Because if that part is repeated in A, then we are not going to consider in B. Okay, na? So that's why consider this entire part, because overlapping occurred. A is overlapped with B. That means we are considering only one time. So like that I have already told, if repetition is there, we are not going to consider two times. That repetition we are not going to consider, one time only we are considering. Even you see Venn diagram, A is covered, A portion of A, at this particular portion A is covered with B. That means we are viewing only one portion. Means the common part is represented, or our common part is considered one time only. Now I am going to explain intersection. So what is intersection? So what do you mean by intersection? So generally by using intersection operation, we can select the common elements. Suppose A is containing some set of elements and B is containing some set of elements. So by using intersection operation, we can select the elements which are common between A and B. But in set format, I can write A intersection B equal to, for all values, whatever the values you include in A intersection B, so the selected value should belong to both A and B. Your condition is the resultant set A intersection B must contain the values within that belonging to both set A, set B. So I can write X for all values of X which are included into A intersection B, such that X belongs to A, the symbol is under, and X belongs to B. X belongs to A and X belongs to B. If you see Venn diagram, let us say this square is universal set. But I am considering there are so many sets in universal set, but I am considering only one or two sets here. Okay, na? The A intersection B. So which is the common part here? This portion is the common portion. The overlapping portion is the common portion now. Okay, na? So that common portion, our target is selecting that common portion now. Okay, then I will explain one example. Suppose if you take 1, 2, 3, 4 and 1, 3, 5, 7. So these two are normal sets. 1, 2, 3, 4 and 1, 3, 5, 7 are normal sets. Okay, na? Then so what are the common elements here? 1 is there in this and 1 is also there in second set. 2 is not there because 2 is there in A but 2 is not present in B. 3 is there in A, 3 is there in B, and 4 is not there in both the sets. Okay, then set A is over. Then whatever the values remained in B, we are not going to consider because we are going to, our target is selecting common elements. Then set A is over. Then whatever the elements that are there in B, those are treated as extra elements. Is it clear now? Then what are the common elements now? 1 is one element and 3 is one element. Those two are common elements. Okay, na? So this is about set. Then what is disjoint set now? How can you represent disjoint set? Suppose if you want to represent disjoint set by using Venn diagram, these two are disjoint. This is A, this is B. What do you mean by disjoint? There is no common element in two sets. Then we cannot get this particular portion. Disjoint means those two are disjoint each other. Okay, na? So there is no commonality. Then what is A intersection B now? Always the disjoint sets A intersection B is 5. Suppose if you take 1, 2, 3 here, 4, 5, 6 here. Suppose set A containing 1, 2, 3 and set B containing 4, 5, 6. So these two are treated as disjoint. A equal to 1, 2, 3, B equal to 4, 5, 6. So 1, 2, 3 is not present in, 1, 2, 3 elements are not present in B. Then we say that these two are disjoint. Then what is the intersection B? The target of A intersection B is finding common elements. Is there any common element now? There is no common element because sets are represented with a universal set like this. Okay, na? So there is no common element. Then always disjoint sets intersection is 5. Okay, na? So this is about intersection. Then what about set difference? Next operation is set difference. So what do you mean by difference now? Here in this difference, if we take any two sets A and B, generally we represent A and B difference as A minus B. A and B difference as A minus B. Then how can you treat A minus B now? Suppose two sets are there. Two sets are there. Then A minus B means we are removing the common elements. So, okay, na? Suppose if elements are present in A and B, they simply remove the elements which are present in both the sets in A and write all the remaining elements of A. Write all the remaining elements of A. That is the target of A minus B. Okay. So what is A minus B now? For all values of X should be belonging to A and that should not belong to B, because we are removing common elements. Whatever the elements that are there in B and A, we are cutting those elements or we are removing those elements in A and we are writing resultant set A. Okay, the target is writing resultant set, but we are removing common elements. See here, suppose if we take A equal to 1357, B equal to 567. A equal to 1357, B equal to 567. What are the common elements in A and B? 5 is there in A and B, 7 is there in A and B. 6 is not there in A. Then after removing consideration of 5 and 7, whatever the elements that are there in A, so those elements are treated as A minus B. Okay, na? A minus B means simply subtracting B from A. Okay, na? So like this we can calculate A minus B. If you see Venn diagram, you should not consider up to this part, because commonality also we are not going to consider. Okay, complete B we are removing. From the consideration. Then whatever the elements that are there in only A, this is only A. We are not considering intersection part. Only A we are considering. So that's why this is A minus B. Okay, if only A if you consider, if you remove common elements, then we say that is the difference between A and B. Then what about set difference of two disjoint sets? So what do you mean by disjoint set now? I already mentioned here, A is this, B is this. These two are disjoint sets. Then what do you mean by A minus B? Is there any common element? There is no common element. Then the first set means A is the resultant set of A minus B if two sets are disjoint each other. If two sets are disjoint, generally we need to subtract the common elements we need to remove common elements from A. Okay, na? Common elements from A. We are supposed to return the resultant set A. Is there any common element in two disjoint sets? No, there is no common element in two disjoint sets. Then A minus B is always A only. A minus B is always A only. So this is about set difference. So next operation is complement. So what do you mean by complement? Complement means we are omitting that particular set from consideration. Suppose in universe there are so many sets combination, related sets. Suppose if you take all the boys related sets, So boys means they are studying in so many colleges. So in each college we are gathering boys related set. Means if we combine all the boys related sets, we get a universal set of boys. So like that. So in universe there are so many universal sets. So here we are considering a universal set. Out of that particular universal set, there are so many sets. So our target is calculating complement of one particular set. So what do you mean by complement of one set? Our target is complement means we are simply removing that particular set from the universal set. So the target is writing all the remaining elements, all the remaining sets or remaining elements from the universal set without A. So that is called as complement. If you see, so generally universal set is written as either mu or u, whatever it may be. Either mu, universal set can be represented by either u, mu or u. You can consider any representation. Now here our target is calculating the complement of A. So what do you mean by complement of A? So like A, there are so many sets in U. So combination of all these, union of all these sets is U, or mu or U. Okay, na? Then we are going to calculate complement. So what do you mean by complement? I already given. So complement means considering the entire universal set without A. Consider all the sets in the universal set without A. Now assume this is universal set. Okay, now one set is A. So then what is A complement now? Except A, we are not considering this. So whatever the selected portion, we are considering that portion only. So except A, whatever the sets that are included in U or U, we are considering that. Except A, we are considering all the remaining elements of universal set. That is called as complement. Suppose if you take universal set is 1, 2, 3, 4, 5, 6, 7. Assume universal set is containing elements as 1, 2, 3, 4, 5, 6, 7. Now A is containing elements as 1, 3, 5. Then what do you mean by A complement now? What do you mean by A complement or A bar? We call it as A bar or A complement, whatever it may be. Then what is A complement now? Simply we are subtracting the total A from universal set. Then we can write it as U minus A or mu minus A. U minus A or mu minus A. We know the difference. Just simply calculate the difference between universal set and the given set A. Universal set and the given set A. Then simply remove the element C. Remove element C. What is A? 1, 3, 5 is A. Then don't consider 1 and 3 and 5. So we are omitting 1, 3, 5 from the consideration and simply we are writing A complement as the remaining elements. What are the remaining elements now? 2, 4, 6, 7 are remaining elements. 2, 4, 6, 7 are remaining elements. So these are the elements. This is universal set and this is the given set and we are going to calculate this set related complement. The given set related complement. Then this is the resultant set of that particular complement. Is it clear? The rest of the elements are without A. That is called as A complement. So this is about complement of A. The next one is Cartesian product. So what do you mean by Cartesian product? Suppose if 2 sets or n sets, you can take any number of sets. Okay, na? The Cartesian product is represented as A cross B, or A cross B cross C cross D, or A1 cross A2 cross A3 cross. Suppose if number of sets are n, then A1, A2, so on, An are sets. Then A1 to An, the cross product between A1 to An, we can written it like this. But how can we represent that particular A cross B as a set? Okay, na? Then collect all the pair of elements. Collect all the pair of elements. That pair should be ordered. Means, suppose if you take 2 sets, one set is containing some elements, another set is containing another element. Yeah, some other elements. Then A cross B means, what do you mean by A cross B? Collect the pairs and combine set A and set B as pairs, pair of elements, and whatever the pair you select, that pair should contain first element should be belonging to first set and second element should belong to second set. Like that we need to pair. That's why we call all the ordered pair of elements, and first element should belong to first set, second element should belong to second set and so on. I have already written here. Okay, now suppose if you take the n sets A1 to An, then Cartesian product of n sets is A1, A2, so on An. Then what about the resultant pair now? This is the each pair representation. X1 to Xn. This X1 should belonging to A1. This X2 should belong to A2. So on Xn should belong to An. That's why I written like Xi belongs to A. If you replace I with 1, then X1 belongs to A1. If you replace I with 2, then X2 belongs to A2. If you replace I with 3, then X3 belongs to A3. Like this, we can write. Okay, so Cartesian product is represented as A cross B, or n elements, n sets are there, then A1 cross A2 cross so on An. But the resultant set is containing pair of elements. Resultant set is containing collection of pair of elements. Then that particular pair, that pair should cover all the sets. But the pair should contain ordered elements. What do you mean by order? So whatever the elements you represent, suppose if n sets are there, we need to collect all n elements in each pair. First element should belong to first set and second element should belong to second set and so on. Nth element should belongs to n set. I will show you an example about this Cartesian product. Now I am going to explain the A cross B example. Suppose if we take A equal to 1, 2, 3, B equal to 4, 5. Okay, the Cartesian product is represented as A cross B. What I told earlier in the definition. So collect all the pair of elements. Okay, na? One element should belong to first set and another element should belong to another set or second set. Like that, we should combine all the elements in A with all the elements in B. All the elements in A with all the elements in B without leaving any element from consideration. That means you must consider all the elements in A and all the elements in B. Then how can we combine? First take first element in the first set and combine with all the elements in the second set. So 1, 4 is the first combination. 1, 5 is the second combination. And select second element in the first set and combine with the remaining element, combine with all elements in the second set. Then 2, 4 and 2, 5. Next, select third, like that. If the number of elements are n, then combine all n elements with the n elements in the D. Okay, na? But finally, you have to show the first element is there in first set, second element is there in second set. Here also, first element is there in first set, second element is there in second set. Like that, we need to pair the elements. Then only we get Cartesian product. In the definition itself, I have already given. Okay, na? So the example of Cartesian product is this. So the next operation is equality of n tuples. Or n tuples are n tuples. Suppose if we take two ordered elements, two ordered pair of elements. Suppose if you represent one ordered pair is 1, 2, 3 and another ordered pair is 2, 1, 3. Okay, na? So equality of n tuples means, so whatever the tuple numbers you consider, those tuple numbers, the respective locations, that those two collections should contain the same number. The collection should contain the same number. Then only we say those two are equal up to n tuples. Okay, now suppose if we take if we take the size of n as 3, size of n as 3. So that means we need to take first three elements from the first set and the first three elements from the second set. Okay, na? So here I consider the first three elements as 1, 2, 3. The next three elements as 2, 1, 3. Okay, na? So the first position in first collection 1 is there. In the first position, second collection 2 is there. In second position 2 is there. Here 1 is there. So both are not matched. Here these two are matched, not matched. These two are not matched. Of course, this one is matched. Even one is mismatched. Even one is mismatched. Then we cannot treat them as equality of n tuples. Here we consider only first three elements in one set and first three elements in second set. Just I represented those two sets within the braces like this, less than symbol and greater than symbol. Okay, na? Then after comparing those two, the position wise, the elements should be matching each other. Okay, na? So if one is the first element, then one should be there in first element in the second collection. If 2 is the second element, 2 should be there here. If 3 in the second element, third element, and 3 should be there. Then we say that those two sets are equal up to n tuples. Equal up to n tuples. Suppose if I take two sets, 1, 2, 3, 1, 2, 3. Okay, na? So 1, 2, 3 is there in the first set and 1, 2, 3 is there in the second set in the first three positions. Then we say that set is those two sets are equal up to n tuples, mean 3 tuples. But in disjoint sets, if we relate it to disjoint sets, what do you mean by disjoint set? There is no common element in the disjoint set. Obviously, we get inequality of n tuples in disjoint sets. Even if we can relate these disjoint sets to previous examples. I have already shown in previous examples. Even if you go to the set difference or any other operations, just we take two sets as disjoint and we can perform operations like this. Okay, na? Then what is the last operation? Last operation is find of I. So what is the purpose of using find? Generally find is used for finding the given element. Suppose if you want to suppose some 2 to 3 sets or 5 sets are there. If you give element 1 or element 2 or element 3, so our target is finding the in which set that particular element is present, or that particular element is there in which set. Our target is finding that element is there in which set. The target is finding set name. Simply we say the find is used for returning set name. Okay, na? See here. So used to find the element I in this set. Okay. So ultimately the target is returning set name is the target. Suppose if we take A equal to 135, B equal to 246. Here I am taking disjoint sets. If we take joint sets, if we take non-disjoint sets, that element may present in more than one set, but finding is like the first, we must stop at first occurrence. Suppose if you take 1, suppose 1 is there in 3 sets. A is containing 1, B is containing 1, C is also containing 1. In normal sets, first apply find operation on A. Check input as 1 and compare 1 with all the elements in A. If 1 is present, then we should not continue this. We should stop here because 1 is already presented. Then we should stop at the first occurrence. We should stop at first occurrence in normal sets. Then we simply write A is the set name which contains 1 as result. Suppose if you want to find how many sets is containing 1, in that case we are supposed to compare that 1 with all the remaining sets. And wherever you find 1, we simply display that particular set name. Like that we get number of sets which contain this element 1. But in disjoint sets, all the elements are different. There is no common element. Wherever you find that particular element in set, we can simply stop there because that element should not present in other sets because those two sets or those n number of sets are disjoint. Okay, if you take 1, 3, 5 as one set and 2, 4, 6 is another set. Suppose find of 3. What do you mean by find of 3? What is the purpose of find? Find operation is used for finding element 3 is there in which set. Here I consider two disjoint sets. In two disjoint sets case, first we should start with the first set. If element is not present in first set, then go to second set. and compare the element with the second set. If second set is also not containing 3, simply we write that element is not present. Otherwise, if that element itself present in first set, we are talking about disjoint, then we can simply stop here. No need to go to next set whether that particular next set is also containing the given element 3 or not. Like that, we can find how many sets are there in, how many sets are containing number 3 in normal sets. But these two are disjoint. So find of 3 is simply writing A because returning A because A is containing 3. And find of 6. 6 is there in only one set. 1 is there in only one set because these two are disjoint. Then find of set is returning D. Then no need to go to search other sets because all the other sets are containing different elements. In disjoint, in normal sets, at the first occurrence, we need to stop, find the operation because that number may be there in other sets also, but we need not search all the other sets. Suppose if you want to find how many sets are containing this number, then only we are supposed to search all the remaining sets also. So this is about the operations of the sets, normal sets and disjoint sets. So thank you for watching my video. Thank you so much.